Number 1, we got V is the volume of a cube with as length x. So cube means all sides equal. So volume is side times side times side, length times width times height, but all x, so x cube. So here V is x cubed, and the cube expands as time passes. Find dv over dt in terms of dx over dt. So just take the derivatives of both sides. That means dv over dt. So we are taking derivative with respect to x. Sorry, with respect to t, I meant rate. So taking derivatives of both sides with respect to t, we get dv over dt. And here, from the chain rule, we get 3x squared times x prime, which is dx over dt. And this is it for this particular question. And number 2, if A is the area of a circle with radius r, that means, what is the formula? Area of a circle is pi r squared, and the circle expands as time passes. Find dA over dt, that's the rate of change of area, in terms of dr over dt in terms of r. So basically we are asked to differentiate both sides with respect to time t. So just take the derivative of both sides with respect to t. That gives us dA over dt equals, pi is constant, in this case r is a variable. Okay, I mean that's the only one thing, at least one thing in the left and one thing in the right should be a variable. So r squared is 2r, so 2 and pi is pi r times, we are doing derivative with respect to t, times r prime, which is dr over dt. Okay, that's it in part A. Now in part B, it's the same question, but some information is given here. Suppose oil spills from a ruptured tanker and it spreads in a circular pattern. It's just like a circle. If the radius of the oil spill increases at a constant rate of, so radius of oil spill, so this radius increases at a constant rate of 1 meter per second, how fast is the area of the spill? So this is the whole area. How fast means dA over dt. The rate of change of area is what? Because this is constantly increasing, so the area is constantly increasing. We want to determine the rate of change of area at the moment when the radius is 30 meters. So at the moment when the radius is 30. In fact, it's the same idea. So we got a circle. So we start with A equals pi r squared. Area of circle is pi r squared. Differentiate both sides with respect to time. We got this. Now dA over dt is to be determined. R at the moment when r is 30, and dr over dt equals 1. So let's plug in. So using A, we can determine the rate at which the area of spill changing is 2 times pi is just pi, okay, about 3.14, never go for decimals, times r, that's at the moment when radius is 30 meters, and dr over dt is 1, and that is in fact 30 times to 60 pi, and this is area. So 30 is meters, 1 meters per second, so meter is square. Our area is a square meter is squared per second. Okay, let's move to number 3. each side of a square is increasing. So we got a square and no variable is assigned, so we can say x, all sides are equal in a square. Each side is increasing at a rate of 6 centimeters per second. So dx over dt, the side rate of change of side is 6 centimeters per second. At what rate is the area of the square increasing? So when the side is increasing, the whole area is increasing. Now we want to determine the rate of change of area. Okay, at what rate is the area of the square increasing when the area of the square is 16 centimeters square? So at the moment when area is 16 centimeters square, because the area is constantly changing, but at the moment when area is 16, how fast is the area changing? So we need to write down the relationship between area and side x. We know area formula, that's just length times width. In a square, length and width are same, so just x squared. Now we differentiate both sides with respect to time just to determine the rate. So differentiate both sides with respect to time. Okay, that gives dA over dt. Our derivative is 2x times x prime from the chain rule, which is dx over dt. Now let's plug in given information and find the unknown. So dA over dt, that's what we were asked to find, equals 2 times x. We are given a but not x, so we'll find in a moment, times dx over dt is given 6. So x is missing. Read the question. I mean, we are trying to determine the rate of change of area when the area is 16. At the moment when area is 16, but we needed x at that moment. So we can use the same formula, the same relationship between a and x, use the same formula to determine this missing x. Okay, most of the time we use the same. So when a is 16, let's do on side, a equals x squared. So 16 equals x squared. Take a square root both sides, we get plus minus 4. By the way, square root of 16 is always positive 4, but when we take square root of x squared, we get absolute value of x. That's how we get plus minus. Plus minus is because of x, not square root of 16. Anyway, this is plus minus 4, but length is always positive, so positive 4. So this x is 4, and that's the answer. 8 times 6, 48. That's the area. So this is centimeters, this is centimeter per second. So area means centimeter square per second. Final.